In this video, I will talk about the properties of logarithms. Now let's start with this. Log a to the base 2 is equal to x. That means 2 to the power of x is equal to a. So 2 to the power of x is equal to a. And in that case, x is equal to 3. Another situation here. Let's say log 9 to the base 3 is equal to y. Then that means 3 to the power of y is equal to 9. So 3 to the power of y is equal to 9. In that case, y is equal to 2. Okay, so that's the general logarithms. Now, let's look at its properties. Before I talk about the properties of logarithm, let's set some restrictions first. So here, a is the base here. So a has to be greater than 0. And a has to be all real numbers. And of course, right, a is not equal to 1, because if a is equal to 1, then 1 to the power of something will be equal to 1. So that's not the purpose here. Now, here, in logarithm, right, let's say log to the something to the base a, right? A log of something to the base a. This something here has to be greater than 0. Because you cannot put a negative number here, then this log will not give you an answer. Okay. Here. In this example here, log a to the x to the base a. In this case, right, x here has to be all real number. Now x can be negative here because as long as a is positive, right, which is what I said here, and it's all real number and it's not equal to 1, then even if x is negative, 1 over something, a positive number, is still a positive number here. Because this just need to be greater than 0. So that's fine. Okay, how about this ones here? Let's say log x now to the base a, or log x of 1 times x of 2 to the base a, or log of 1 over x to the base a, or log of x of 1 over x of 2 to the base a. In this case, what will be the restriction for x of 1 and x of 2? Now notice that whatever that's inside here needs to be greater than 0, has to be positive. So in this case, right, x here has to be greater than 0. So it has to be positive. The product has to be positive too, right? So x sub 1, x sub 2, they need to be positive number. I understand that, right? Two negative number multiplied by each other will give you a positive result too. But in this case, let's just set it equal to positive number. Same thing here. Just set that equal to positive numbers for both x sub 1 and x sub 2, right? So x has to be positive number too. So in this case here, I have to say that, right? x of 1, x of 2, they have to be all real positive number. Okay. How about this example here? Log x to the power of y to the base a. In this case, y can be positive or negative. Similar to this one here. Right? So I can say that y is all real number, right? How about x here? Okay, but x has to be positive, because if you have negative y, right, negative value here, 1 over a negative number is negative. So x has to be all positive real number. Okay, so these are the restrictions that I want to set before we talk about the properties of logarithms. Okay, so the first one here. Now, a to the power of log x to the base a is equal to x. Now let's look at this here. Now I'm going to let k equals to this here, log x to the base a. That means a to the power of k is equal to x here. And this one here, I said log x to the base a is equal to k here, right? So I can rewrite this one as a to the k equals to x. Okay, so this and this are exactly the same. So this proves this. Okay, now, next, the second one, log a to the power of x to the base a is equal to x here. Okay, this one is simple. Now, a to the power of x is equal to a to the x, right? So I can directly say that, okay, a to the x is equal to a to the x, right? Okay, next, the third one, log y to the base a is equal to x. Okay, in this case, what does that say? That really says that a to the x is equal to y. Okay. According to this, right? What we did here, right? Okay. The fourth properties. Log x sub 1 times x sub 2 to the base a is equal to log x sub 1 to the base a plus log x sub 2 to the base a. Okay, how do we prove this? Now, first of all, let log x sub 1 to the base a equals to k sub 1 and log x sub 2 to the base a equals to k sub 2. Okay. From here, we can say that a to the power of k sub 1 is equal to x sub 1, right? So a to the power of k sub 1 is equal to x sub 1. And from here, we can say that a to the power of k sub 2 equal to x sub 2, right? A to the power of k sub 2 is equal to x sub 2. Now, multiply x sub 1 with x sub 2, like this one here. So x sub 1 times x sub 2 is equal to a to the power of k sub 1 times a to the power of k sub 2, right? Okay, we have the same base a here. So when you multiply the same base with an exponent, what do? You add the exponent. Now, a to the power of k sub 1 plus k sub 2. That's the property 2, right? Okay, now go back to here. This one here. Since we said that x sub 1 times x sub 2 is equal to a to the power of k sub 1 plus k sub 2, we can replace into here, right? Okay, so here, log x sub 1 times x sub 2 to the base a is equal to log a to the power of k sub 1 plus k sub 2 to the base a, right? So this is equal to this, right? According to this here. And what's that equal to? Well, according to the second properties here, right? Here, log a to the power of x to the base a is equal to x. So that means over here, this should give me k sub 1 plus k sub 2, right? Okay. And what is this here on the right side? We did say that this is equal to k sub 1 here, and this is equal to k sub 2 here, right? So the right side here is equal to k sub 1 plus k sub 2, right? So we can say that log x sub 1, we don't need the bracket here, plus log x sub 2 to the base a is equal to k sub 1 plus k sub 2. Okay, so this side here is equal to k sub 1 plus k sub 2, and this here equals to k sub 1 plus k sub 2. That means these two sides are equal, right? This one and this ones are equal, right? Exactly what we're trying to prove here, right? They are equal here. Okay, so log x sub 1 times x sub 2 to the base a is equal to log x sub 1 to the base a plus log x sub 2 to the base a. Okay, that's a proof here. Okay, the fifth properties. Log 1 over x to the base a is equal to negative log x to the base a. Okay, to do that, again, let's let log 1 over x to the base a equal to k, right? And negative log x to the base a equals to w. Okay, what does this mean here? Now, it means that a to the power of k is equal to 1 over x. A to the power of k is equal to 1 over x. On this side, let's multiply both sides by negative 1. So we have log x to the base a is equal to negative w. Now, this means that a to the power of negative w is equal to x. A to the power of negative w is equal to x here, right? And this would become 1 over a to the power of w equal to x. Now, just take 1 divided by x, you get a to the w. Okay, so a to the power of w is equal to 1 over x. Now, this is 1 over x, this is 1 over x. That means a to the power of k equals to a to the power of w, right? So we can say that a to the power of k is equal to a to the power of w. That means k is equal to w. What did we say k and w are? K is equal to this side and w is equal to this side. We just proved this, that these are equal, right? Okay, so we just proved that log 1 over x to the base a is equal to negative 1 log to the x to the base a. Now, number 6. Let's do it here. This one here, log x sub 1 over x sub 2 to the base a is equal to log x sub 1 to the base a minus log x sub 2 to the base a. Okay, let's do this again. Let log x sub 1 to the base a equals to k sub 1 and log x sub 2 to the base a equals to k sub 2. Okay, that means a to the power of k sub 1 is equal to x sub 1, right? So a to the power of k sub 1 is equal to x sub 1. And on this side, a to the power of k sub 2 equal to x sub 2. A to the power of k sub 2 equals to x sub 2. Okay, now we have to take x sub 1 divided by x sub 2, right? Like this one here. Okay, so x sub 1 divided by x sub 2 is equal to a to the power of k sub 1 over a to the power of k sub 2. Okay, so It's the same base a here. That means this is equal to a to the power of k sub 1 minus k sub 2. Okay, now what to replace x sub 1 over x sub 2 with a to the power of k sub 1 minus k sub 2 into here, right? So log x sub 1 over x sub 2 to the base a is equal to log a to the power of k sub 1 minus k sub 2 to base a. Now again, this will give you, now based on the second properties here, right? This here will give you x here. That means this one here will give you k sub 1 minus k sub 2. Okay, we know that. We said this is equal to k sub 1 and this is equal to k sub 2. So on the right side, it's equal to k sub 1 minus k sub 2, right? So here, log x sub 1 to the base a minus log x sub 2 to the base a is equal to k sub 1 minus k sub 2. So the left side is equal to k sub 1 minus k sub 2, and the right side is equal to k sub 1 minus k sub 2. That means these two are equal. This proves this properties. Okay. So log x sub 1 over x sub 2 to the base a is equal to this. Log x sub 1 to the base a minus log x sub 2 to the base a, right? Okay, now number 7, log x to the power of y to the base a is equal to y log x to the base a. Okay, here, for all y are real numbers. Okay, so now here, what do we do? Let log x to the power of y to the base a equals to k, and here, this one here, y times log x to the base a equals to w. Okay. On this side, a to the power of k is equal to x to the power of y. That's what it means. On this side, let's divide both sides by y. We have log x to the base a is equal to w over y. Now, this will mean that a to the power of w over y is equal to x. What we want to do now is take the power of y on both sides, right? So that it cancels out here. So this one will become a to the power of w equals to x to the power of y. Okay, from here, this is x to the power of y. This is x to the power of y. That means a to the power of k equals to a to the power of w, right? So a to the power of k is equal to a to the power of w. That means k is equal to w. And what did we say k is equal to and w is equal to? Well, k is equal to this side and w is equal to this side. So this proves this identity. Okay, so we can say that log x to the power of y to the base a is equal to y times log x to the base a. Okay. Now, number a, log a to the base a is equal to 1. Okay, that's simple. because a to the power of 1 is equal to a, right? Number 9, log 1 to the base a is equal to 0. That's simple too, because a to the power of 0 is equal to 1. Right? Okay. Next. Let's talk about the change of base formula. Okay, number 1, log x to the base a is equal to log x to the base b is a different base than this one here, over log a to the base b. Okay, notice that on this side here, this is x and this is a, and this is x, this is a here, right? And the base will be the same on this side. So it doesn't matter what this base b is, as long as they're the same, then this will equal to this side. Okay, let's prove this. We will let log x to the base a equals to k, and then log x to the base b equals to w, and log a to the base b equals to h. What does this mean here? Well, that means this is equal to w over h, right? So I will place all this with what I just set those equal to. Okay, here. From here, this means a to the power of k equals to x, right? A to the power of k is equal to x. From here, that means b to the power of w equal to x. And from here, b to the power of h is equal to a. Okay, so what I will do is, here, on this one here, b to the h to the power of 1 over h is equal to, on this side, same thing, right? Then h and h cancel out, we have b equals to a to the power of 1 over h. Now we can replace b into this one here, right? So this one will become a to the power of 1 over h to the power of w is equal to x. So this will become a to the power of w over h is equal to x. Now x and x equal to each other, so this equals to this, right? That means we can say that a to the power of k is equal to a to the power of w over h. This means that k is equal to w over h. So this is the same as this. So we just prove this. Okay, next. First of all, for b is not equal to 0 in this case, log x to the base a to the power of b is equal to 1 over b log x to the base a, right? Because b here cannot be 0. You cannot divide something by 0. Okay, how do we prove this? Again, let this one equals to k, and this one equals to w then. What does this mean? That means a to the power of b to the power of k is equal to x. So I can directly write this a to the power of b times k, right, in the exponent is equal to x. And on this side, let's multiply both sides by b first. So we have log x to the base a is equal to b times w. That means a to the power of bw is equal to x. Okay. Well, in that case, right, this is x, then this and this equal to each other. A to the power of b times k is equal to a to the power of b times w. That means b times k is equal to b times w. Divide both sides by b, we have k equals to w. What do we say k and w's are? Now k is equal to this, w is equal to this. This proves that, this property, right? Okay, so here. Okay, hope you enjoyed this video. Don't forget to subscribe to my channel. Thank you.